Welcome everybody to the Data Center Facility track. I hope that you are enjoying the presentations today here at the Regional Summit. I'm here to talk to you about the OCP Ready Data Center Facility Colocation Facility Program. I'm Brevan Reyher. I'm the Open Compute Project Lead for the Data Center Facility Group, and I'm here with Gerard Thibault. What is the program? It's a set of guidelines for the deployment of Open Compute racks, which lays out the information regarding OCP racks and hardware. In particular, around the differences from traditional IT deployments and the impact it has on the data center facility. The guidelines are community developed, industry influenced, and foundation supported. Extending from the guidelines is a checklist and scorecard which help support the OCP Ready program. The checklist details the foundation requirements, while the scorecard focuses on the must-have attributes for the architectural, electrical, and mechanical systems. These are the must-have attributes that enable the deployment of OCP racks and hardware. Now you might ask, why do we need this? Why is this necessary? Well, there were OCP users who started adopting Open Compute hardware, but they found challenges when they were trying to deploy in colo facilities. The community and foundation asked, how do we mitigate against these issues? And what initially began as a simple document of guidelines associated with OCP hardware morphed and grew and evolved into an actual defined program for certifying OCP-ready colocation facilities. We've talked about what it is and why it's necessary, but I think we should be clear on what it is not. The OCP Foundation is not a certifying body, nor do we have third-party auditors associated with the guidelines, checklist, and scorecard. The data is self-reported by the colo facility provider, and then it is presented and reviewed by the community. There's no audit performed on the facility to verify the data, and at that point, all claims by the colo provider should be verified by the end user, the OCP adopter, as part of their normal contracting and procurement processes. In addition, it does not cover facility design, life safety requirements, security, or any compliance pieces. All of those requirements are believed to be unique to each individual OCP company and organization, and we cannot create a guideline around that. Now we'll cover what the process for being recognized is. So at this point, a colo provider is familiar with the guidelines. They understand the process. They understand the checklist and the scorecard. They'll contact the project lead. At that point, they'll be provided with any more information if they have any questions, and we'll provide them with a repository as well as their own blank scorecard or official scorecard and checklist to fill out. They'll go ahead and complete the self-audit using the guidelines and scorecard. They will upload all of the supporting information, whether that be design drawings, compliance, anything, to support the scorecard. Then they'll come and participate in the data center facility call. They'll introduce their company, they'll go through their scorecard to be able to allow the community to ask any questions or request any additional information to support their application for this OCP Ready program. After that's been completed satisfactorily, they will receive approval from the incubation committee as a OCP Ready provider. After that, there is Open Compute requirements from the foundation, and there are other requirements for the marketplace listing and becoming a colo solution provider as part of the foundation. Those will need to be completed. And you're sure you're asking, what does a solution provider, a colo provider, get from participating in this program? First of all, being a member of the OCP organization, you are allowed to use the logo associated with your membership level in all your branding and marketing. From the marketplace, the OCP team will provide you with Google Analytics data from your click-throughs. Each facility that you get an OCP Ready mark for goes towards your contribution requirements for your membership. You will also, as part of the program, you receive the OCP Ready trademark, which you can use in your branding, and the Open Compute Colo Solution Provider trademark and logo for your branding. Finally, as part of the OCP marketplace, which I think you've heard in many presentations, is growing and is being built, you will have a listing for your facility on that OCP marketplace. Make it easy for OCP adopters to go ahead and find your company and your site. Now, getting to the marketplace, the requirements associated with that, sort of a repeat, but you must be a corporate member in good standing. You can be any level of corporate member, from community, silver, gold, or platinum. You must have completed and be a colo solution provider. You must have completed all the legal documents and executed them associated with your membership, your copyright, as well as the solution provider legal document. You must have gone through the recognition process that we spoke about earlier. You must have paid all of your applicable fees to be a member, to be a colocation facility provider. And last but not least, the foundation requests that a specific landing page is provided on your corporate website so that the click-through from the OCP marketplace to your website creates a cohesive branding and user experience. Now to the pilot program. In order to test the scorecard process, the Foundation selected 2 organizations to participate in the pilot program. The selection of KO Data and Rackspace allowed feedback from the European and North American organization perspective, and both of them were existing members of Open Compute. Both had data centers to serve the European market, which coincided well with the timing of the program launch as well as this regional summit. You'll also see that these facilities are state-of-the-art and they have designs that support the OCP tenets: efficiency, scalability, openness, and impact. So now I'm going to hand it over to Gerard, from KO Data, and he'll provide feedback on the program as well as introduce the KO Data facility.
Good morning, everybody. Hear me okay? I'm going to talk a little bit about how we've gone through the process of becoming audited, or not audited perhaps, but assessed for the Open Compute Ready pilot program. Just to give you a little bit of background about myself, I've been in the data center market now for 20 years, so seen an awful lot of data center facilities through that 20-year period, and hopefully bring some of that experience to the facility project within Open Compute. For the last 11 years, I worked for a major data center REIT, and probably been responsible for the design and development of about 80 data center suites and 150 megawatts worth of capacity over 24 facilities across mainly Europe, but also through Asia and Australia as well. So I think hopefully some of that experience sort of comes through in what we've pulled together. We heard yesterday from John Laban about being passionate for the subject, and clearly he is, and I think we try and sort of bring that passion to the design of the data center, pull through all of the requirements that we think the community needs. We had some initial meetings with John and Mark Dansie, Steve Helvey, actually out at our data center. We launched the data center in February of this year. And really what they did was give us a sort of insight into what the program's all about. And we'll touch on some of those points as we go through the slides. We actually did a detailed tour, a couple of detailed tours of our facility, which is in London, in the London market. And as part of that process, we worked with Mark Dansie, who you can see just sitting there, he probably raised his hand there, who is, if you like, the gatekeeper of the scorecard. So he's really helping sort of the Open Compute team define what goes on that scorecard in terms of the requirements. I think it's interesting listening to the presentations this morning from Brian and so on, and Stein, is if you know what the requirement is for a specific application, it becomes a lot easier to design a data center that meets those requirements. If you're designing as KO does for a speculative market, it becomes a little bit more generic, so you have to leave some things with flexibility. What is the purpose of the scorecard? I think Brevan obviously touched on that. Really, it's to define that list of really essential items that a data center needs to cover the majority of requirements, not only for OCP, but principally for people who are going to adopt the OCP technology. I guess really it's an amalgamation of all of those standards that are in the market. Got a few of them there, not exhaustive, but TIA 942, uptime, EU Code of Conduct, all of those things that basically we as engineers look at in pulling a data center together. And the key sort of takeaway from this, as Brevan touched on, is that the 5 critical elements that really are the generic requirements of a data center. So it's IT space, so how do you use the facility? What space is there to put your equipment in? How is it going to house the OCP servers? The cooling. Cooling's a major element to the data center in terms of sustainability, energy, operating costs. If you think about the fact that the electrical requirement for driving a data center costs you 40% at least of your operating costs for a data center, trying to make that as efficient as possible is obviously tremendously important, and we'll touch on how we do that in our facility. Electrical systems, we've heard this morning from Rob Bunger particularly about how you organise those. Do we just have raw mains backed by generators and allow battery backup units? We'll touch on that a little bit more. Monitoring and control is obviously very important, and the session before with Brian Kelly actually gives you some more possibilities for giving yourself a bit more sort of application-specific control, and maybe the ability to chop out some of the 50% that Stein identified earlier on. And then facilities operation. Clearly it's important to maintain the facility, keep it running as efficiently as possible, and that drives down costs as well. Got some little graphics there of our facility. I think it looks quite sexy, but I'm slightly biased. The facility we opened is in the London data centre market. We're actually on the northeast sort of quadrant, if you like, of London, just outside the M25. We launched it in February this year after probably a 2 to 3 year development cycle, including trying to find power and so on, getting through the planning and the permits. The campus approach gives us up to 36 megawatts on the campus, with 4 buildings equally sharing that load, so 8.8 megawatts, and in 4 suites of 2.2 megawatts each. Some various other statistics there, but we'll go through some of the more important elements of it. So looking on the IT side, so one of the 5 sort of key attributes, we've got a couple of pictures there about how the facility looks. Clearly what we've got to do is maintain security at the facility. We've got to make it suitable for bringing OCP equipment in as well as other cabinets. One of the things we've focused on is making sure that we can cope with up to 58U cabinets. So really giving people to the ability to use the power in the footprints within the data hall. Sometimes with smaller cabinets we end up finding that people run out of cabinet footprints before they run out of power. So giving them that ability to use 58U, where you can roll them in straight onto a loading dock, either via tail lift or a sort of curtain-sided lorry using a scissor lift, means that you can wheel those through, all the way through goods lifts up onto the 2 floors above ground where the data centres are. Goods lift, 2,500 kilograms. We've learned something through the process. In actual fact, we should have made that another 500 kilograms more. What we're seeing is that OCP racks can go up to 1,500 kilograms a time. So we've got a lift that will take 2 cabinets in terms of volume, but unfortunately won't do in terms of weight. So that's something for us to learn and take forward into the next process. I think the other thing that we really sort of picked up on is removal of raised floor. It's something that we've been developing through some of the projects I've done at my previous job. Obviously with the OCP racks and the weight, having that sort of element of raised floor just creates a problem in terms of distribution of the equipment and the loads. So we've stripped out the raised floors and we've just got a sealed concrete floor. That's at 15 kilonewtons per metre squared, so it will easily support that sort of 3,300 pounds of IT load, or 1,500 kilograms. And everything within the space is arranged really to give you that front access, top access that OCP sort of is based around. We use a buzzway distribution system as our basis of design. Avoids the raised floor and the whips or large overhead cableways with lots and lots of cables, difficult to manage. And importantly for us, because we don't know who we're designing for specifically, we've got no columns in the space at all. So that gives a lot more flexibility. So the way we've planned the space is to actually give us up to 13 technology cells within that space that can be moved anywhere within the room. But that can be flexed. We can put cages in to subdivide the space and so on, and it isn't interrupted by columns and constraining the layout. So I think that probably hits most of the areas on the actual IT or physical layout. We then move on to cooling, and we've chosen to use an air-based system. We actually use what we call an indirect air system. It's actually based around a company called Flat Woods. But what we try to do is incorporate a system that we can use other manufacturers within the market. There's probably 4 or 5 in the market that are sort of competent and able to deliver the systems. What we do is effectively have a fan wall. So you can probably see a sort of corridor here where we blow air into from the units out on a gantry at the side of the facility. That has a perforated wall so that we equalise the pressure along there and allows air to then filter into the complete room void. So it's very low velocity, unhindered in where it goes to. So effectively we just allow the servers to draw air from that sort of bathtub of nominally 24-degree air and then go through into the hot aisle. We then capture the hot air and return it through a ceiling void back into where the red arrow goes out to the external equipment. A couple of things that does for us is that with all the equipment being outside, we can actually play to the strengths of the EU Code of Conduct, where equipment can be added as load grows. So you can start with 25-30% of the cooling equipment and grow as you fit out the IT. Generally, the way we've arranged the space is that we're based on a 5 kilowatts per cab, but something that we pick up as part of the monthly call with the Open Compute Foundation, and that's looking at the trends for growing loads. And I think generally we're seeing sort of that 10 kilowatt as being the sort of mean. Yes, you get some up at 30, but ultimately, as long as the cabinet can take enough air through the front of the cabinet and cool, then our design will support those loads. Performance, I think this is one of the key things, particularly in a data center that's designed for a sort of speculative load. We've actually tried to have a system that gives us a very flat PUE response. As you'll see there, starting at very low loads of 25%, we go from 1.23 through the range, dipping a bit in the middle, up to 100% operation at 1.21. And those are sort of annualized figures, and we prove those during the testing. We actually use, as I said, the flat group indirect air cooling system, and that has an aluminium plate heat exchanger, but we have no mechanical refrigeration components within the system at all. And we can still, in the London market, deliver the ASHRAE recommended cooling envelope. What we do is just in the peak summer months, we use water to spray in and get an adiabatic effect and also evaporative cooling. It's quite important because during my experience at the data center REIT, we found that probably 80% of the portfolio was operating at less than 50% capacity. So that real mid-range for us is very important to offer that to clients with a really good PUE. Again, coming back to if you've got a defined requirement, it becomes a lot easier to design a system that will work, but on a speculative basis, we think this is really something quite groundbreaking. In terms of what that means to customers, if you go back, and maybe some of these figures are a little out of date, the latest Uptime Institute global survey showed that the average PUE is about 1.58. So we're a little bit out here, but you can gauge from here what the savings could be. But if you go back to 2014, the numbers there were about 1.7 as a global PUE. If you compare that to what we're operating at 1.2, you can actually save on an 8.8 megawatt building about £3 million a year in terms of energy saving. And that's quite impactful really in terms of the overall operating costs. I guess one of the things that having a cooling system that uses far less of an overhead is it drives down your requirement for electrical backup systems and cable, so adds to the sustainability of the facility. What we tried to do is build in as much flexibility in our facility as possible. Again, as I said, because we're hitting a sort of speculative market, we've actually gone for a centralized UPS within each data hall as the basis of design. We can flex that so that we can just provide a raw mains generator back supply to each hall, or we can do individual UPSs within the space, or even obviously support the OCP rack with the battery backup units. Really depends to who's going to go in there. So we'll try and talk to customers when they're coming in if they're going to have a new hall that's fitted out from a raw condition. But if necessary, we can actually switch out the UPS and then redeploy into another suite if we need to. I think obviously one of the things that you need to look at with the OCP battery backup units is obviously local regulations. We heard about the German case where you can't put the battery within the space, but also the economics as well. Is it more economic to provide one UPS to cover the whole installation if most of the infrastructure needs it, or do you go back down to the rack and groups of racks accordingly? So again, you need some real thought about what you're designing for. Backup facilities, again, this is something that sort of plays into, I think, the EU Code of Conduct, is that we've got a centralised generator facility. quite resilient in terms of the controls that we use, so it's a dual redundant control system. We synchronize with the mains so that we can actually do online testing of the generators throughout the operation of the building, and we do that on a regular basis. Nobody even blinks an eyelid anymore. They wouldn't know whether they're on mains or generator. But importantly, because we've got that central aggregated amount, just as Brian was talking about, Rob was talking about the redundancy and aggregation of power supplies within the OCP racks, we can look at the facility load and actually grow the generator load to support it as we need it, avoiding spending unnecessary capex to begin with. Monitoring and control. So this is perhaps the fourth pillar of what we're trying to do as part of the data center project. Environmental control really drives the whole efficiency strategy. We've got the ability, as I said, to control to the ASHRAE recommended, and we achieve those figures of a sort of mean 1.2 PUE. But what we like to do is to talk to our customers and get them to work within the allowable. We heard from John Levan this morning about OCP servers being quite happy to take 40 degrees in. So within the UK climate, we're probably talking of 3 hours a day within 10 days in 3 months worth of weather where we're going to exceed the sort of 27 degrees. So I think it's very important if we understand what the equipment is that we're putting in there. Is it legacy? Is it all OCP? And then we can help choose the envelope that people work to. But certainly we can achieve that, and as I said, all without refrigeration. The other thing we do as part of trying to maintain customer warranties is certainly with the sort of traditional servers. With the move away from lead solder to silver solder, there is a risk of contaminants in the air, especially if you're using external air to cool the data center. We actually use a recycled air as through the indirect system, but you still have to provide some fresh air into the data hall. Obviously, we've all got to breathe when we go in there to maintain it. ISA 71.04 really constrains what we need to do in terms of meeting contaminant pollutions. So we've put in a series of monitors, and I think we're probably the first wholesale company to do that. So Purafil have been working with us, and effectively we monitor the predominantly chlorides and sulfides in the air, in the atmosphere, and make sure that we always monitor and deliver a G1 atmosphere. Within the standard there are 4 different classifications, and that's G1, G2, G3 and GX. GX means that you will have a failure of your electronic equipment because either the solder will corrode or the circuit boards themselves will. So I think it's very important that that comes into the monitoring aspect of the data center. Right, operation there. Reduced operational costs, that's one of the big things for us. I think cooling, taking out the mechanical refrigeration, the equipment really gives us that ability to give ourselves a sustainable type of cooling system. We've taken out the refrigerants, so it helps on global warming potential, power consumption, cable sizes go down, generator sizes going down, transformer sizes go down. Really, it's a way of actually stripping out some of the capex as well. And increased availability. You know, if you look at the cooling units we use compared to a traditional chiller with lots of compressors, evaporators, effectively we've got a box with and I'm sure David would sort of push back on this. It's very simple. It's a heat exchanger with 2 sets of fans, one circulating the data center air, one circulating the external air to get rid of the heat. So very, very simple, and then just the addition of the water spray. Less waste, less components, that should drive a lower operating cost in terms of maintenance, and certainly should drive better availability, which is ultimately what we're all striving for within data centers. And with that, I will hand over to Brevan again. Hopefully I've hit my time.
changing hats a little bit. I'll reintroduce myself. I'm Brevan Reyher. I'm the design and build engineer for Rackspace Hosting. I serve in the global data center infrastructure group, and I'm also the engineering technician lead for the Rackspace Colocation product. Rackspace has been an OCP member from the founding as a platinum member, and we've been supporting our customers for over 20 years. In 2013, Rackspace knew that we would need additional capacity in our London region. And so we set out to design and build a state-of-the-art data center with the capacity to satisfy our long-term growth needs. We partnered with the best in the industry, and the LON 5 data center was designed and built. It's located in Crawley, south of London, and it was officially open for business in 2015. The initial shell has 4 3-megawatt data halls for a 12 megawatts of total capacity. Using the latest technology, I think you'll find a lot of similarities between these two sites for various reasons, but we were able to achieve a design PUE of less than 1.2. We also use some other technologies such as rainwater harvesting to reduce our need for domestic water supply. In the DC access and white space area, we implement all rows with a separate hot aisle containment to separate the supply and return air. We also have a concrete slab floor that eases the deployment. The entire data center is on one floor, and it is a common level from the loading dock to the deboxing area all the way to the operational space. This eases deployment and operations. The power within the data hall is delivered via overhead busway, and as well as all connectivity is delivered via overhead cable trays and cable distribution. One of the most impactful design changes that we made from a traditional data center is the use of the adiabatic and evaporative indirect air cooling units. They're mounted on the roof. The alignment of the design set points to the ASHRAE 2011 thermal guidelines is what allowed us to use these units. And with that, we were able to eliminate the compressors, saving a lot of energy overall. The use of hot aisle containment, as mentioned before, allows the air to return to the air units with the return air plenum. And this provides an increased delta T back to the cooling unit, which increases the capacity and efficiency of that heat exchange. The UPSs and generators are also deployed in an N+1 distributed redundant fashion. They're mounted on the roof above the IT equipment. This allows us to connect the UPS output boards directly to the busway distribution in the space, eliminating the use of any isolation PDU or additional wire length. This reduces the electrical losses for that wire, as well as the CapEx for deploying those additional PDUs in infrastructure. So sort of a simplified design. As well, with that distributed redundant design, you'll find the individual utilization of each one of your UPSs is increased because you're not using 40 to 50%, you're using 70 to 75% of that UPS on a regular basis. We also, with the N+1, it's concurrently maintainable, as well as its adequate failover capacity for when you do lose a UPS or are undergoing maintenance. Within the data center, in order to maximize the efficiency, LED lighting is used throughout the entire space. As well, to aid the human comfort factor of our data center operations group, light tubes are brought from the ceiling down into the core to bring natural light in during the day to the office space. The data center has 24/7, 365 security operations. Two-factor biometric authentication is required to get into the facility, as well into each one of the data halls. Closed circuit video monitoring and 90-day retention are standard in all rack-based facilities. But the design is great, but as Gerard mentioned, it's all for naught if you don't have the operations to keep that facility running at its highest level. So Rackspace is a highly disciplined, world-class data center operations with global documented policies, processes, and standards. All of it is backed by our fanatical support promise with a global support organization to support the customer needs. We partnered with industry-leading facility operations to operate and maintain the critical facility infrastructure. And we provide carrier-neutral connectivity to the site to connect the data center to the outside world. And last but not least, for those customers that choose to connect to the and leverage the Rackspace network backbone, we provide a 100% network uptime guarantee. So in terms of the project and the program, you can contact me as the OCP project lead at the OCP email. If you're interested in discussing further with KO Data or Rackspace regarding co-location of gear, then you can contact us at our individual company emails. If you're in the EMEA region, Mark Dansie is always happy to talk to people about coloing, and we're actually looking for somebody as a group in the North American region that may help facilitate co-location providers within the North American region. So if y'all know anybody, let us know, and we'll get on with them. So some additional links regarding the program. The Open Compute website. We also have the Data Center Facility Project Wiki, and we're working to build out a Data Center Facility Project Wiki for the colo solution providers, which will house all of the information and will allow the open publication of any of that data. Right now we're finalizing some last legal aspects associated with the OCP Ready Mark as well as the Colocation Service Provider, and we've set a date of November 1st to have that fully out as general availability. If you're interested in joining the project, I think I mentioned earlier during Rob's, we're looking at re-incubating and the individual components associated with the data centers and really trying to push the limits of what we can do in terms of efficiency, scalability, openness, and impact. Thank you for your time. If you have any questions, me and Gerard will be able to field them.
Thanks. Yeah, Brevan, I just wondered if you had any sense of, in the demand from customers, what the mix was between people who want to bring in fully loaded racks or people who want to actually just turn up with OCP compliant hardware and slot it into racks that are already in place in the data center.
I would think that whenever you look at what I see in the market is a lot of the OCP users are working with a solution provider, and that is they are integrating that rack somewhere else and bringing it to the data center. I know that all of the open compute that Rackspace deployed was deployed as fully open racks. I can tell you Microsoft and Facebook and all of those are deploying open racks. And I think it depends on the scale at which you are deploying. But if you also listen to Aaron Sullivan, who's really talking about to maximize the efficiency of open compute, you really have to think of your deployments at a rack scale. And so I think I would say that it's leaning towards more full rack versus individual growth.
This is more a general question because yesterday I attended the advanced cooling solution, then this morning modular data center, and then now. In all these sections, the cooling system that has been discussed are a little bit different because liquid cooling, immersed cooling, door cooling, in-row, and evaporative. Does it make sense to open a project in OCP dedicated to the cooling facilities where all of these can be included in the OCP project, anyone with its own characteristic, of course, but that all of them has the requirements for OCP?
It's a great idea. What's your name again?
It just sounds like you volunteered.
Yeah, exactly. So that's what I'm speaking of when I talk about taking the data center facility group and separating those focus areas and getting the right people involved with discussing cooling, focusing on cooling. You have expertise and experience in cooling, and you have a motivation to improve efficiency and change it. I feel like we need to bring those individual groups together. The same way that you have rack and power, they're very focused on rack and power, and they do a lot of good things there. I think that the data center facility group is very wide and broad, and we need to sort of break it apart and focus in particular areas. So yes, exactly. I think that when you look at modular, chilled water, DX versus a general colo data center starting to move to the indirect or like Facebook the direct, there are major differences that can be aligned.
Yeah, that is actually the differentiating factor for OCP, making the rack and the room a system, because you can have many of the individual benefits also with traditional computing, bringing in full racks or leveraging like higher rack units like 2U and then subdividing that like that way. But by standardizing the facilities in the room and the air or other cooling solutions that you provide at the room level and at the rack level, you can actually bring them together and then try to leverage synergies to save more energy and make operations a lot easier. That is what traditional designs can do.
I think if I could just add on the cooling systems, I mean, obviously if you've got a very uniform operating platform like the OCP can deliver and it's in big enough scale, if you can actually go to direct chip cooling or submerged cooling technology, actually you can get a better grade of heat that actually you could then use to export out of the data center and bring the overall ecosystem to be more efficient.
It's not just that. You have standardized power with the power bar at the back.
Yep.
It's line in units. The connect is made. You have not standardized yet network connectors. Traditional computing does that with blade centers chassis, but it's not really interoperable between vendors. But you could easily also make network connectors if you slide in. You don't just connect the power, you also connect the network. So there's actually zero connecting to be done. You slide in the unit, it's operational. You could do the same also with connectors for advanced cooling solutions.
Yep.
So that liquid connectors are being made automatically and are sealed automatically.
Yep.
And then you could bring liquids to the rack or into the unit even automatically. And that is not even more maintenance for the personnel in the room when they install more nodes or when they do node maintenance. So that is not yet done, but that is all potentially possible when you have a system that incorporates room and rack and plans both together.
Yeah, I mean certainly we see some of the liquid cooling systems with negative pressure water systems where you could have that sort of plug in and then as you snap you don't get any leakage. So that's great, but because as I said we're a sort of speculative data center, we don't know what's going in there. It's the air transfer that we find.
OCP
that,
as a project.
Yeah, sure.
Because only when you have those standards and then manufacturers and builders of data centers working towards the same integrated standard, only then you get the synergies and the benefits from them.
Sure.
Yeah, I myself and I know a lot of the other data center facility community are keeping an eye and participating in the advanced cooling project to get in front of any of those facility connections that might have to be made to support the different products.
In the telco project, Christian, there is facility to have connections at the back of the rack with fibre connectivity. So the CG Open Rack 19 has fibre connectivity at the back. So I think that's where we need the telco project and our project to come together to share common, common designs. So, yeah.
If there's nothing else, we'll go ahead and end this session, and we have Green Mountain coming up.